my dear students. How are you all? This video is the third part of your chapter Upthrust and Flotation and Archimedes Principle, and our topic for today is flotation. We are going to study principle of flotation, relation between the volume of submerged part of the floating body and the density of the liquid and the body, then application of principle of flotation. So how the iron ship floats, human body floats, so we will learn the various things about it related to your Archimedes principle and principle of flotation. The first thing is principle of flotation. You have learned that when a body is immersed in a liquid, two forces act on it. The weight of the liquid body, which is acting downwards and through the center of gravity of the body, and this force has a tendency to sink the body. Then secondly, the upthrust is acting. The upthrust is the characteristic of the liquid. The upthrust acts vertically upward through center of buoyancy, that is center of gravity of the displaced liquid. So this force has a tendency to make the body float. So what does principle of flotation say? It says that the weight of the floating body is equal to weight of the liquid displaced by its submerged part. When a body is in fluid, these are the two forces acting. So what is the apparent weight of the floating body? When a body is floating, what is its apparent weight? Apparent weight means it does not have its real weight when it is inside the liquid. You must have seen that an object which appears heavy in air, when you dip it in water, it appears lighter. Why? Because the buoyant force balances some weight of the object. That is called, the false weight of that object is called apparent weight when it is inside the water. And how do we calculate it? What is the formula? True weight minus upthrust. If a body is floating completely immersed in water, then its apparent weight is 0. It appears as if the body has no weight. This is principle of flotation. Now, relation between the volume of submerged part of a floating body, the density of the liquid and the body. So let the body is floating with a volume V immersed inside the liquid. The density of the liquid is rho L. Then let us consider the density of the body as rho S of the substance, we can say. So in that case, the formula is ratio of volume of immersed part of the body upon total volume of the body is equal to density of the body upon density of liquid. This is the formula for finding the density of a body which is immersed in a liquid. For example, a cube of ice will have 90% of its volume immersed in water if density of the ice cube is 0.9 gram per centimeter cube and density of water is taken as 1 gram per centimeter cube while floating. Because its density is 0.9 and if we convert it into percent, it will be 90%. So how much part of the ice cube will be outside water? Only 10% will be outside the surface of water. So what do we understand from this? That a floating body of higher density has its more volume submerged inside the liquid, hence it experiences a higher upthrust than the body of low density. Now, depending upon the weight of the body W and the buoyant force Fb, there are three possibilities. If W is greater than Fb, that means weight of the body is greater than the buoyant force, then the body will sink. In this case, the apparent weight of the body, that is the weight of the body inside the liquid, if you attach a spring balance to that body, then the apparent weight will be W minus the buoyant force, which will be acting vertically downward. And in this case, the center of gravity and the center of buoyancy, both points will coincide. the body will sink in this case. Second case is W is equal to FB. It implies that the body will float just inside the surface of water. When the body is inside the surface of water, body is somewhere here, totally inside the surface of water. In that case, we consider W is equal to FB. Weight of the body is equal to buoyant force. The apparent weight of the body will be 0 in this case. And we have density of such a body is equal to density of the liquid. And in this case also, the center of buoyancy and center of gravity are at the same point. B stands for center of buoyancy here, and G stands for center of gravity. Now, third case, if weight of the body is less than the buoyant force, in that case, we will see that half of the body is outside and half of the body, even more than half, we can say some portion of the body gets submerged and some portion of the body is outside. So only that much. Now how much portion will get submerged? Only that much portion of the body gets submerged by which the weight of the displaced liquid it becomes equal to the weight of the body. That means this is submerged part, whatever weight, whatever liquid it will displace, that weight of the liquid and the submerged weight of the submerged part will be same. Only that much part of the body will be inside, and we will say that much buoyant force only will act on the body, because weight is also a force. So you can say that the weight of the submerged part of the body is equal to the buoyant force acting on the body, and whatever is the center of gravity of that much portion which is submerged, that becomes the center of buoyancy for this body. And in this case, center of gravity is up at a higher place, and the center of buoyancy is below it. Note some important points here. A floating body of high density has its more volume submerged. Definitely, if the density of the body is high, it will submerge more inside the liquid and it will experience more upthrust. Why? Because when it will submerge more is the weight of the submerged part, more will be the weight of the liquid displaced by the body, and more will be the buoyant force. A body of different densities. So a body floats in the liquid of different densities only and only when the density of the body is less than and equal to the density of the liquid. So the volume of the body submerged in the liquid will decrease with increase in the density of the liquid. And in each case, the upthrust by the liquid on the body, that the weight of the liquid displaced by the submerged body is same and is equal to the weight of the body. So what we understood by this, that a body floats in different liquids with different amount, a different part of it being submerged depending upon the density of the liquid. Now let us understand some application of this principle of flotation in our day-to-day life. First is flotation of iron ship. You have seen that iron ship has a very big volume. This bigger volume iron ship floats on water, whereas if we place an iron nail on the surface of water, it sinks. The reason is that the density of the iron, because the density of iron is greater than that of water, so weight of the nail is more than the upthrust of water. Whereas for the ships are also made up of iron, then you can say why they do not float. This is because the ship is hollow from below and the empty space in it contains air, which makes its volume large, and therefore average density means its density of all its part. Average density becomes less than that of water. Therefore, only a small portion of the ship is submerged in water. And how much the ship will submerge? It is equal to the weight of the liquid displaced by that volume of the ship. Then a loaded ship is submerged more while an unloaded ship is less submerged. Yes, you understand that when cargo is loaded on the sailing ships, its weight increases, so it sinks further to displace more water, and therefore if the ship sinks more. And if the cargo is unloaded, the ship will rise in water till the weight of water displaced balances the weight of the unloaded ship. Then also a ship begins to submerge more as it sails from sea water to river water. You know that the density of sea water is more than that of the river water. So the density of, and you also must be knowing the density of water of different seas is also different. Therefore, when the ship sails from a sea of higher density to a river of lower water density, it sinks further. Then flotation of human body. Human beings are able to float on water as the average density of the body with empty lungs is 1.07 gram per centimeter cube, while with lungs filled with air is 1 gram per centimeter cube. So when a good swimmer floats, he fills his lungs with air and nose and mouth he keeps just above the surface of water, and he keeps on displacing water. So the weight of the water displaced by him is then nearly equal to his own weight. Thus he swims with very little effort. Then also we know that it is very easier to swim in sea water, and as it is quite dense as compared to fresh water. The reason is that sea water have higher density. Example is the Dead Sea. In the Dead Sea, the density of water is much more. That is 1.16 gram per centimeter cube. Therefore, a man can easily swim in Dead Sea with a small portion submerged inside water. Next is flotation of submarines. Submarines is a fish-shaped watertight boat provided with several flotation tanks. So a submarine can be made to dive into water or rise up to the surface of water as and when desired. How does it do so? If a submarine is to dive inside, its ballast tanks or the flotation tanks, which are at the bottom of the submarine, are filled with water, then the average density of the submarine becomes greater than the density of the sea, and the submarine dives into water. But when it has to rise up, the water from the ballast tanks is given out into the sea by allowing the compressed air to enter the tank. Compressed air, now the ballast tanks are filled with air. So this makes the average density of submarine less than that of the sea water. Therefore, the weight of the water displaced by its partially submerged part becomes equal to the weight of the submarine, and hence it rises up to the surface of water. So it also can be explained, flotation of submarines can be explained on the principle of flotations. Then come flotation of iceberg. Let us understand this also. Here you can see the icebergs in the sea. The density of ice is very less than less than the density of water, and we know that density of ice is 0.917 gram per centimeter cube, whereas that of water is 1 gram per centimeter cube. So huge masses of ice known as icebergs are able to float on water with their major part inside the water surface, only a small portion, 1/10 of the portion inside, 1/10 of the portion outside the surface of water. So icebergs are this way very dangerous for ships. They, being lighter than water, they float on water with their only 10% part outside water. So it becomes difficult for a driver of the ship to estimate the size of the iceberg if he has no knowledge of principle of flotation. So thus an iceberg is very dangerous for a ship as it may collide with the ship and cause damage. Then how do the fishes float? Actually, many fishes have an organ called swimming bladder. It acts as a ballast tank. You heard about ballast tank of submarines? So it acts as a ballast tank, and when the fish has to rise up in water, it diffuses gas from its fluid into the bladder. So its volume increases and average density decreases. Then this increases the volume of the water displaced by the fish. So the upthrust on the fish increases, due to which it rises up. And when it has to come down inside the sea, it empties the bladders. This is how upthrust on the fishes decrease and they go down inside the water. This is how fishes float. Then we can also understand. Now let us understand the rising of balloons. You must have enjoyed in your lifetime the rising of balloons in air. It looks very beautiful. How does it rise? When a light gas like hydrogen or helium, whose density is much less than that of air. Density is less than that of air. Now you must have got the idea that when density is less, the object will float. When this gas is filled in a balloon, the weight of the air displaced by the inflated balloon becomes more than the weight of the gas filled in the balloon, and thus it rises up. But the balloon, it does not go up indefinitely. The reason is that the density of the air decreases with altitude. Therefore, as the balloon gradually goes up, the weight of the displaced air decreases and it keeps on rising as long as the upthrust on it exceeds its weight. When the upthrust becomes equal to its weight, it stops rising further. So this is about rising of balloons. So children, these were the few examples, the applications which you understood based on the principle of flotation. Remember these points. The principle of flotation states that when an object floats on a liquid, the buoyant force that acts on the object is equal to the weight of the object. Displaced volume of the fluid is equal to volume of the object which is immersed. If the weight of the object is greater than upthrust, the object will sink. If the weight of the object is equal to the upthrust, then the object is balanced, making the object to float. So, thank you for watching the video.